Hi guys, let us continue with the module 1. So today's topic is expression for energy density in terms of Einstein coefficients. So for that, first we had to consider atoms with two energy levels E1 and E2. This we have learned this. So atoms are at energy level E1 and E2 with populations N1 and N2. I'll explain this clearly in further discussions. So we'll directly go. So for this, we are using one absorption and two emissions for these processes. We consider three processes: absorption and other two emission. Okay. Now first let us understand what is induced absorption. I already said what is induced absorption. In simple terms, I'll tell again. A photon comes. This is a photon. So this is a photon. A photon comes. It gets absorbed by an atom. When an atom is absorbing this photon, it jumps to the higher level. Okay. It is going to jump into the higher energy level. This is nothing but what? Induced absorption. So for this, we are expressing in terms of formula as B12N1UV. What is this B12? B12 is nothing but Einstein coefficient. Okay, this is Einstein coefficient for induced absorption, which means it tells us the probability of an atom absorbing this photon. Okay, sometimes it may absorb and sometimes it may not absorb. So this sometimes is nothing but chances, probability. So that probability is defined as Einstein coefficient. We can tell this as absorption probability also. Okay, then N1. What is N1? N1 is nothing but number of atoms in lower energy state. Okay, in this lower energy state, how many atoms are there? That is only N1. I'll write here number of atoms in lower energy state. Okay, this is induced absorption. Next we will see spontaneous emission. What is spontaneous emission? I'll tell again in very simple terms. Atom in higher energy state, there is an atom in the higher energy state. It is on its own. Now it falls down without any external force. When it falls down to the lower state, it emits a photon. Okay, this is called as spontaneous emission. Then how we are describing it in terms of formula is A21 N2. Okay, this is in terms of the formula. Similarly as this one, here A21 is the Einstein coefficient of spontaneous emission. That is probability we can tell. Okay, then next is stimulated emission. Remember these three. See, this is equation 1, this is equation 2. We'll consider them as this is equation 1, this is equation 2. Then next we have stimulated emission. What is stimulated emission? I said you. So in stimulated emission, atom is in the highest state, it is falling down. Atom is in the highest state, it is falling down, but it is getting triggered by a photon. When it is getting triggered by a photon, it is going to release another photon while falling down of the same energy as this one. Okay, so here P1 is equals to P2. These two photon is having same energy, same direction and same timing. That is nothing but stimulated emission. So here we are writing it as B21N2UV. Okay, this is the formula for stimulated emission, where B21, this B base 21, this is nothing but Einstein coefficient for stimulated emission. Now, this is equation number 3. Now, we will see energy density at thermal equilibrium. What is energy density at thermal equilibrium? It is nothing but balance between the absorption and emission. We have two energy levels. Here also we have atoms and here also we have atoms. It is what is thermal equilibrium? In simple terms, I'll tell. It is nothing but the atoms coming down and the atoms going up. This both are equal. Okay, so the rate of emission and the rate of absorption is equal. Okay, so now rate of absorption is equals to spontaneous emission plus stimulated emission. So here we used, right, we have written three equations that we are going to add here. Equation number 2 plus 3. Okay, then what do we get? See, here we are rearranging. So we will get UV. This we are bringing this side and we are rearranging it. Once we rearrange, UV is equals to, we will get this. Okay. Then next one, we are using Boltzmann law. What is this Boltzmann law? Boltzmann law is nothing but it will tell us how the particles are spread among different energy level when the system is at a certain temperature. Okay. So formula is this one. You can take this one only. This is better. This is the formula of the Boltzmann law. This is what it is. Then we are substituting into equation 1. This was our equation 1. This was our equation 1. We are substituting that into using Boltzmann law. We are substituting that. So N1 divided by N2. Here what is happening is UV is equal. Here to make them equal, we are dividing numerator and denominator with N2. So once here N2 and N2 gets cancelled, here N2. N2 and N2 gets cancelled. I'll mark this. So this gets cancelled, then it will be 1. This gets cancelled, this will be 1. And similarly here also, see here B21, B21, N2, N2, this all gets cancelled. Then this is also 1. So by doing that only, we are getting this equation here. Okay. After this, when we write, we are simplifying. So we said N1 divided by N2. This formula here we have written, right? N1 divided by N2 is equals to EV power HV divided by KT. So this we are going to substitute in this equation. After substituting into that, we are getting finally this equation. Okay. Once we get this equation, we are going to use Planck's law. What is this Planck's law? According to Planck's theory, the energy density. Okay, the energy density of radiation is. What is that energy density of radiation is what? He tells that this is the formula. Okay. So here we are going to equalize these two. How? See, A to 1, B to 1 and then this one. We are going to equalize these two. Here you can see this. This is for your understanding. Whatever the middle steps are there, for your understanding have written. Okay, so this we are going to equalize those two. So which we can also write that as in this way. So after this, what does this mean? This means that spontaneous emission probability is related to stimulated emission probability. After this, we will write in a simplified form A21, see, A divided by B, this you can see here. So B1 divided by B21 is equals to 1, which means that, what is this meaning? This means that induced absorption, B12 was for induced, B21 was for stimulated. So the probability of induced absorption and the probability of the stimulated emission is equal. Okay. So this we can write it as 1. Now the overall equation, see they have taken that as B, then A21, A base 21 they have taken it as A. So it will be this equation. Equation number 5. This one will be reduced to this one. I hope you guys have understood. Guys, please let me know if you need all the explanation in the Kannada as well. Don't forget to like, subscribe and share. Thank you.